numerical numerical techniques for solving ordinary differential equation. And it is 321 numerical techniques for solving differential ordinary differential equation by Taylor series. By Taylor series. Okay? Are you following? So we'll be looking at this by Taylor series. We have a lot to do here this afternoon. Before we begin to solve one or two problems, let's know the meaning of differential ODE. You know very well that if we have y divided over dx is equals to 3x plus this is a first order differential equation. True or false? It's true, right? Hope you are following. This is a first order ODE. 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 That is first order ordinary differential, first order ordinary differential equations. Are you following? Do you understand? Okay. So this afternoon we are going to do a lot of things. This will remind you of your calculus and advanced calculus, geometric calculus and advanced calculus. Is that clear? Then Taylor series, Taylor series is of the form. Taylor series is of the form y of x is equals to y naught plus x minus x naught times y naught prime all over 1 factorial, then plus x minus x naught all in square all over 2 factorial times y prime prime naught, then plus x minus x naught raised to the power of 3 all over 3 factorial times y naught prime prime plus This is our Taylor series, and we'll be using this to solve numerical techniques for solving ODE, ordinary differential equation by Taylor series. Then before we move further to solve any example, let's numerical calculus. You were taught implicit functions, true or false? Let me just write it boldly. You were taught implicit functions, true or false? Yeah. You were taught this, isn't it? True or false? It's okay. Yeah. Since you were taught this, you taught how to use product rule. True or false? What is your dy all over dx is equals to either u dv all over dx plus v du all over dx. True or false? It is, right? Yeah. So if you agree with me, I think this will help us in terms of this ODE, or want to look at. This will help us, and implicit function, you know very well that implicit functions are this one, either x, y squared plus x squared y. True or false? Let's just say equals to 0. And you are asked to find the y all over the x. True or false? So let's fix this example. Let us use this example so that by the time we begin to differentiate ordinary differential equation using this approach or product rule, we will not find it difficult. Is that clear? Are you following? Do you understand? Okay, so let us consider this. Please take note of what you want to do now. It's very important. Take note. It will help you guys. It might be a compulsory question. Please take note. Okay. Yeah. So now let's look at it together. Let's look at it. So if we are to differentiate this, this is d all over dx, open bracket x y squared plus d all over dx, open bracket x squared y. This is equals to 0, right? So we have to differentiate this. We hold this. We differentiate x, hold this one constant, right? If you differentiate, what are you supposed to have? You are supposed to have 1. True or false? So it means 1 times y squared, you have y squared dx all over dx, because this dx means you differentiated for x. Then differentiate whole x constant, differentiate y, is that clear? Differentiate y. Let me use color. I don't know whether that color will be. Okay, differentiate y squared. If you differentiate y squared, you are going to have 2y. True or false? Then you need to multiply, so plus 2xy dy all over dx. True or false? This means you differentiated for y. True or false? Are you seeing it clearly? Okay. So hope you are following. Are you following? Okay, so let's proceed. So now the same thing applicable here. We are going to do the same thing. Differentiate y s squared over y. You are going to have 2xy dx all over dx. Then plus differentiate y whole 2x squared whole s squared. Sorry, we are going to have, you have 1, use it to multiply this. You have x squared dy all over dx, which is equals to 0. True or false? So this and this will cancel, this and this will cancel. So therefore we have y squared plus 2xy dy all over dx plus 2xy, amen? Okay? Then plus x squared dy all over dx equals to 0, right? Okay. So as you can see, we collect like terms. We have dxy dy all over dx plus x squared dy all over dx equals to, if this crossing the sign equality becomes minus 2x. Yeah, is that clear? So it means what we need to do here is what we need to do here is I think what is common on the left hand side, dy over dx. You factor it out, so dy all over dx, open bracket 2xy plus x squared equals to minus 2xy minus y squared, right? Amen? Then we divide through by this, therefore our dy all over dx is equals to minus 2xy minus y squared all over 2xy plus x squared. Yeah. So this is our final answer. So the most important thing how to differentiate implicit function. Is that clear? So with this knowledge, I think we'll go far. We can go far with this knowledge. So please don't forget to share this live class. Don't forget to share this live class. So let's proceed further. Let us proceed further to solve example, and this example we want to solve, it will do you good. Okay, let's proceed further. Yeah. The example says use Taylor series method. Use Taylor series method. Obtain the solution. Obtain the solution of dy all over dx is equals to dy all over dx equals to 3x plus y, and y equals 1, and y equals 1 when x is equals to 0. Find the value of y for, find the value of y for x equals to 0.1. Please, your calculators will be needed here, so get ready. Yeah, so this is where the question stops. It's simple as ABC. Look at the question very well again and again. Is that clear? So now let's do justice to this question. This question is very important to you guys. It's very, very important. Okay. Yeah. So let us consider to solve this problem. So we write solution. You know, in the Taylor series we have x, y naught, and x naught, two of us. Yeah. So our x naught is equals to 0. Then y naught is equals to what? 1. And our our differential equation is given as dy all over dx equals to, this is our ODE, 3x plus y squared. Please, you have to listen attentively because it will do you good. Yeah, you know we have to differentiate this function. Is that clear? Before we begin to differentiate, if we have dy all over dx and we are to differentiate this derivative, again, already it is in first other derivative, true or false. So if we are to differentiate it again, we are going to have d squared y all over the x squared. Take note, because we want to do something similar, something. So we are going to differentiate this function up to fourth time. That is, sorry, this ODE, ordinary differential equation, up to what? How many times? 4 times before we can able to use Taylor series. Is that clear? Yeah, you can go up to 5 times, 50, no problem. Yeah, so let's differentiate this. It means we are differentiating both the left hand side and the right hand side. Is that clear? So if we are to differentiate this, I told you that you were taught implicit function, true or false. So let's do it. Let me just break it down for you. Let's do it this way. It means dy all over dx. If you agree with me, d all over dx, open bracket 3x plus all over dx, yeah, open bracket y squared, right? True or false? At least with this way you can understand it clearly. Is that clear? With this way you can understand it clearly. So this implies that we should differentiate what is inside. Amen. Yeah, let's differentiate what is inside. If we differentiate this, it means we are going to have the left hand side d squared y all over the x squared. Then equals to, differentiate this with respect to x, you are going to have 3 dx all over the x plus differentiate this with respect to y, since y is the only function here. So we are going to have 2y dy all over the x, true or false? So it means this second order derivative, we are going to have d square y all over the x square equals to this cancel, 3 plus 2y dy all over the x. Do you understand? Any question before we proceed? Please, if you have any question, ask. If you have any question, ask, so you will see this. If you have any question, please ask. If you have any question, ask. I'll be grateful to respond to your question. Please try and like the video, very important, and share it, your Facebook or TikTok, anywhere, your work. Okay, if there is no question, we can proceed, right? So you can now see that we assume this first one as equation 1. This is equation 2, right? Okay, so let's move further to differentiate this function again. This differential, the second order differential equation again. This is where the problem some of you will not understand. You'll be confused, but it's simple as ABC. If you know your product rule very well, it means we are to differentiate this, the left hand side and also this side, true or false. So if we differentiate d squared y all over the x squared, we are going to have d cubed y all over the x cubed, true or false. Then function, true or false, is only a constant. So if you differentiate this constant, here is supposed to give you 0. True or false? It's true, right? So there, that 3, if you differentiate it, you are going to have 0. That is simple as ABC. Amen? Okay. So far, so good. So, look at here. Here already is 0. We want to differentiate 2y divided over the x. Look at this function, this differential equation very well. You know very well that here we have two functions, true or false. Okay, let us just assume that there is no 2. And we have y dy all over the x. You can now see that we have two functions. We have y as a function. We have dy all over the x as a function. True or false? It's true, right? Okay. So this implies that we are going to use what? Product rule to differentiate this. Already here we are going to have 0. No doubt about that. So let us use product rule to differentiate this. So either we differentiate this, we hold this one constant. Then any this thing we use it to multiply. So let's differentiate this. But here is 2y. So it means here is 2y. True or false? So we are going to hold dy over the x, then differentiate 2y. Then any answer we use it to multiply. Is that clear? So if you agree with me, if we differentiate 2y with respect to y, because it's y that is here, we are going to have 2 dy all over the x times the constant dy over the x. I know some of you will still ask questions. Then plus, since it's product rule we are applying, we use product rule for the implicit function, true or false. Plus, we are going to hold 2y, then differentiate this. Is that clear? If we differentiate this, we are going to have d squared y all over the x squared. Then use it to multiply the constant 2y. So we'll be having 2y d squared y all over the x squared. Please, any question at this point? If you have any question, ask. If there is question, ask. It will do you good. Is that clear? If you have any question, please ask. If you have any question, ask. No question, we proceed further. If there is no question, let us proceed further. Is that clear? Okay, it means all of you understand what is going on. It's okay. Okay, so let's proceed. Let us proceed further. Let us proceed further if there is no question. So, as you can see, it means we are going to differentiate it the 4th time. So, if you can see what I am saying, let's differentiate this. We have 2 divided over the x, and we have what? Yeah, it means this we are going to have, yes, yeah. We are going to have, if you can see what I am saying, if assuming we have 2a all in bracket a, look at it very well. This is the same as 2 open bracket raised to power 2a, true or false? It's true. So this, we can still rewrite this in this form. D raised to power 3y all over the x raised to power 3 equals to 2 open bracket dy all over the x close bracket all square plus 2y d square y all over the x square. Amen? Okay, do you agree with me at this point? You agree with me, right? Okay, so if you agree with me, so let us proceed further. Okay, yeah, so let us differentiate this again. If, okay, it means this is equation 3, equation 3. So if we differentiate this again, it means we are going to have, here will now be d raised to the power 4 y all over the x raised to the power of 4 equals to, differentiate this. Go back to your elementary calculus here. If you want to differentiate something of this form, it means your chain rule, two of us. First consider this. Differentiate this, the whole, the inside. So it means use this to multiply this. We are going to have what? 4 open bracket dy all over the x raised to the power of 2 minus 1 is 1. So it is not necessary you put raised to power 1. Then you now come back to this function inside, then differentiate this function. What is inside there? It means if you differentiate it, you are going to have times d squared y all over the x squared. Yeah, as simple as ABC. Then what we have here plus. Here we are going to use product rule because we have two functions. We have 2y and this d squared y all over the x squared. So your product rule here is necessary. So if you can see what I am saying mathematically, both in the spirit and physical, we can differentiate this function without having any issues. True or false? True or false? True or false? It's true, right? Okay. So let's proceed. Let's proceed. Yeah, we differentiate 2y, hold this one. So if we differentiate 2y, I will use it to multiply what we hold d square y all over the x square. So it means we are going to, if we differentiate 2y, we are going to have what? We are going to have, with respect to y, we are going to have 2 dy all over the x times the constant we hold. We are going to be, it's going to be d squared y all over the x squared, right? Then plus we hold 2y, then differentiate d squared y all over the x squared. So this means we are going to have d cubed y all over the s cubed. Use it to multiply. So we are going to have 2y d cubed y all over the x cubed. So as you can see, this is yeah. Hope I'm right. Yeah. Yeah. So this is equation 4. So this is where we are going to stop. Then we begin to substitute things. If you have any questions, ask. But as you can see, look into this ODE very well. The fourth order ODE. Look at it very well. If you can see what I am saying, let me write it here so that you won't be confused. Plus, I think, okay, yeah, okay, we differentiated this, we got 1, this, then we are going to have 2y d cubed y all over the s cubed. I think this is what we are supposed to have. True or false? Yeah. Okay. So if you can see what I am saying, this, they are the same thing. True or false? We have 4 open brackets. Okay. Let's just put the bracket for this and leave this one. Yeah. So if you can see what I am saying, this and this, they are the same thing. True or false? So it means we can add them up, isn't it? We can add them up to give us, we can add them up to give us d raised to the power of 4 y all over the x raised to the power 4 equals, here we are going to have 6 dy all over the x, open bracket, d square y all over the x square, then plus 2y d cube y all over the x cube. So we can assume this one to be equation 5. Amen? Do you understand? So at this point, we are going to substitute in this and this into equation 1, 2, 3, and 5. Because 4 is the same thing as 5. Is that clear? Do you understand? To obtain our derivative. Because we want to obtain the derivative. Okay? We want to obtain this derivative so that we introduce our Taylor series. You just need the derivative. You know, I told you the other time that when we have first order derivative, this is the same thing as y prime. Then this square y all over the x square is the same thing as y prime prime. True or false? You know, in Taylor series, instead of this, we use this. Is this one we are going to use? So if we have d cube y all over the x cube, this is the same thing as y prime prime, right? True or false? Then d raised to the power 4 all over the x raised to the power of 4. This is the same thing as y IV. True or false? So you should take note of all this. So now we have to substitute in to obtain this derivative, this and this. So how can we obtain them? Since the values of x naught and y naught is given. So I want to clean this up, please. Or you are still writing. I want to clean this up. Okay? So far, so good. So let me clean this up. So if you can see what I am saying from here, can clean here. You can see what I am saying. It means, let's obtain the first derivative. dy all over the x is equals to, at x naught, anywhere you see x is 0, so 3 open bracket 0 plus, anywhere you see y is what? 1, all is square. So this is equals to 1. Then our second derivative, let's consider our second derivative, d square y all over the x square, right? Yeah, this is equals to, this is it. So here is 3, right? Here is 3. We write 3 plus y is what? Y is 2 times y is 1. Then we have dy over the x. True or false? Our dy over the x is what? 1. So you can now see that here we are going to have 3 plus 2, which is equals to what? 5. Do you understand? Then our third derivative, let us obtain our third derivative. I can clean this, right? Okay. Our third derivative will now be d cubed y all over dx cubed equals to our third derivative, okay, is this, that is 2 open brackets, our dy all over dx is equals to what? 1, but here is raised to power 2, true or false? So we write 1 all in bracket raised to power 2. What do we have here? Plus, right? So plus 2y, isn't it? So 2y, what is your y? Your y is given as 1, then 1, open brackets, then d square y over dx square is equals to what? 5. Look at it, this is the answer. True or false? True or false? So here is times 5, then what else again? Nothing else. So this is equals to, this is the same as 1, 2 plus 2 times 1, 2 times 5, 10. Here is equals to 12, right? Then lastly, let's consider the fourth derivative. Can you see now? I hope you are following. Are you following? Okay. Please don't forget to share. Yeah. So here, at this point, we are going to consider this for all over. Yeah. Then this is equals to 6. We have 6 here. 6 times dy over dx is what? 1, right? Times 1. Then we have d square y all over dx square, right? So where is it? Is equals to 5 times 5. Then plus 2y. Y is 1, right? Then times d cubed is equals to 12, right? Then this will be equals to this times this 6 times this 30, right? Then plus this times this 2 times 12 is 24, which is equals to 54. Any question before we proceed further? Do you have any question? Any question? Yes or no? Because get set with your calculators, because we want to use calculator. We want to use calculator. Please take note of this question, please. We want to use calculator here. Okay? So our x naught, so I can claim everything here, right? Okay? So let's recall our Taylor series, right? Our Taylor series. Okay. Yeah. Oh, 0.1 x given x equals to 0.1. Okay, I think so. Yeah. So it means our x naught is equals to 1. Yeah. Okay. So we are moving. Exactly. Then x naught is 0, y1 is 1, right? So let's clean. Let's recall our Taylor series. Amen. Our Taylor series, that is y is equals to f of x, is the same thing. This is equals to y naught plus x minus x naught all over 1 factorial, right? Times y prime naught plus x minus x naught all all square all over 2 factorial, true or false. Then plus x minus x naught all over 3 factorial raised to the power 3 plus x minus, oh sorry, we are missing something, please. The differential y prime prime plus x minus x naught all over 3 factorial raised to the power 3 y prime 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 naught, then plus x minus x naught raised to the powers of 4 all over 4 prime 4 factorial, then y iv naught plus it continues. Okay, so but since this is where we stopped, look at it. First derivative, second, third, and fourth derivative. This is it. So this is our Taylor series formula, and we want to do justice to it by applying using what is it called? Using this and all this, our x naught and y naught. Is that clear? So it implies that our y is equal to y naught is sorry, this is y naught. Y naught is 1. True or false? Is 1. True or false? Is true, right? Y naught is 1. Please get set with your calculators. Y naught is 1. So plus open bracket x y naught is 0. True or false? So we don't need to write 0 again. 1 factorial is the same thing as 1, so it's not necessary. Now what is our y prime naught? Y prime is talking about, you know, I told you the y all over the x is the same thing as y prime. True or false? So our y prime is 1 times 1. Okay? So we are progressing gradually. Okay? So far so good. Then plus x minus x naught is 0, but here is square. All over 2 factorial is 2 times 1. True or false? Then what is y prime prime naught? Y prime prime naught is 5 times 5. Amen. Then plus x minus x naught is 0. So it's not necessary. We put 0. Then raised to the power 3 all over 3 factorial is 3 times 2 times 1. True or false? Then y prime prime is equals to 12. That is our d cube all over d cube y all over dx cube is equals to 12. Then what we have here plus x minus x naught. X naught is 0. So here will be x raised to the powers of 4. Then y iv is 54 times 54 all over 4 factorial. 4 factorial means 4 times 3 times 2 times 1. True or false? Yeah. Do you agree with me up to this point? Are you following? Are you following? Okay. So far so good. We can still break it down. True or false? We can still break this down. Yeah. Here it means our y is equal to 1 plus x plus our Taylor series will be in this form plus 2x cubed, then plus 9x raised to the power 4 all over what? 4. True or false? True or false? It's true, right? Look at the board and tell me. So, yeah. So far, so good. So, it's simple as ABC. Very simple. It is not difficult. Yeah, let's do it together. Now they said we should find x equals to 0.1, right? It means our y of x is 0. What? 0.1, which is equals to 1 plus x plus 5x squared all over 2 plus plus 2x cubed plus 9x raised to power 4 all over 4. So far so good. So this implies that y of 0 is equals to, this is y of x. So anywhere you see x, you write 0.1, y of 0.1, so 1 plus 0.1 plus 5 open bracket 0.1 all in square all over 2, then plus 2 open bracket 0.1, because anywhere you see x is 0.1, because at x equals to 0.1 we should evaluate it. So plus 9 open bracket 0.1 raised to power 4 all over 4. So this is where I'll be needing your calculators. So 0.1 times 0.1, 0.1 times 0.1 times 0.1 again, then 0.1 times 0.1 times 0.1 times 0.1. So just tell us the answer. Is that clear? At first, let us use y naught of 1 is equals to 1 plus 0.1 plus divide, use 5 to divide 2. You are supposed to have 2.5, right? 5 divide 2, please, your answer. 2.05. 5 divide 2. 5 divide 2, please, your answer. I need your answer. Uh, 2.50, right? Okay. Okay. So 2.50. Then what is 0.1? All is square 0.1 times 0.1. Yeah, I want you guys to work so that in the exam you can do it yourself. Answer. Esther. Huh? Going to give us 0.0. Okay, so I think it's better you do the whole thing, the whole summation. So our y, I think our y therefore, okay, yeah, y not of 0.1 is equals to 1.12722. 1.12722. So you just finish these two 9 divided 4 is 2 point what? 2 point 2 2.5, right? So just finish it. Go and finish it. All over 4 point raised to the power of 4. Okay. So this is how you are going to look at it. I will advise you to, at least after taking a rest, have time to visit the video again, because it will do you good. It will help you. Is that clear? So we are going to stop here. Thank you so much for your time. I'm very, very grateful. I love you guys. See you same time, same venue. Please don't forget to share. Thank you and God bless you. Bye. Bye-bye. Love you guys.